Light disappears first, then color, then shape. At depths where pressure crushes steel and temperatures hover near freezing, life does not vanish, it changes. On the deep ocean floor, delicate silhouettes move across sediment like drifting thoughts. Their bodies are long, skeletal, and almost invisible, as if biology itself is trying to disappear. These are sea spiders, creatures that seem less built than erased, their organs faintly visible through ghost-like limbs. Predators pass without noticing. Light fails to reflect. Even substance feels optional. Today, we're diving into why deep ocean spiders grow so disturbingly transparent, and what that transparency reveals about survival where sunlight has never reached. This is not a story of monsters, but of evolutionary compromise, where being seen can be fatal and vanishing becomes the most effective strategy life has ever engineered. The deep ocean is not merely dark, it is optically empty. Sunlight collapses within the first few hundred meters, and beyond that boundary, vision becomes unreliable, then meaningless. Pressure increases relentlessly, squeezing gases, compressing tissues, and eliminating air-filled structures entirely. Temperature stabilizes near freezing, slowing chemical reactions and biological processes. Food arrives rarely, drifting down as fragments from distant surface ecosystems. In this environment, the strategies that dominate life on land or in shallow seas, speed, strength, sharp vision, vivid color, lose their advantage. What replaces them is efficiency. Movement becomes slow and deliberate. Bodies become elongated, fragile, and sparse. Many organisms abandon pigmentation entirely because producing color is metabolically expensive and functionally useless without light. Sea spiders inhabit this world as benthic wanderers, moving across sediments and sponges where nothing grows quickly and everything costs energy. Here, survival does not favor dominance but restraint. Every gram of tissue must justify itself. The deep ocean strips life down to its most defensible form, forcing organisms to exist at the bare edge of biological viability. Sea spiders, or pycnogonids, appear unfinished because evolution has removed everything unnecessary. Their bodies are so reduced that most internal organs extend directly into their legs. There is no centralized respiratory system. Oxygen diffuses passively through the body surface. Musculature is minimal. The abdomen is nearly absent. What remains is a thin exoskeleton and elongated limbs designed not for speed, but for reach and balance. Transparency emerges as a byproduct of this reduction. With fewer dense tissues, less pigmentation, and thinner cuticles, light, when it exists, passes through instead of reflecting back. Even in darkness, this structural minimalism persists because it saves energy. Building opaque tissues requires cellular layers, pigments, and structural proteins that demand resources the deep sea rarely provides. Rather than protecting organs behind armor, sea spiders disperse them. Damage to one limb is less catastrophic when systems are distributed. This anatomy is not fragile by accident. It is resilient through simplicity, a design shaped by scarcity rather than abundance. In a world without sunlight, invisibility still matters. Many deep-sea predators rely on bioluminescence, brief flashes of light used to detect motion, attract prey, or confuse rivals. Against these sudden illuminations, opacity becomes a liability. Any solid body reflects light, revealing shape and distance instantly. Transparency, however, breaks the visual signal. When a bioluminescent pulse sweeps across the seafloor, a transparent organism does not cast a clear outline. Its body fails to return enough light to form a recognizable target. Sea spiders, with their narrow limbs and translucent tissues, scatter these signals into visual noise. Even predators adapted to darkness struggle to track what barely registers as matter. Transparency also disrupts depth perception. Without clear edges or contrast, Distance becomes ambiguous. This confusion buys time, often the difference between detection and escape. In the deep ocean, camouflage is not about blending in with color. It is about refusing to exist visually at all. Food scarcity governs every evolutionary decision in the deep sea. Meals are unpredictable and often small. Decaying organic matter, slow-growing invertebrates, or microscopic prey scraped from surfaces. For sea spiders, hunting is inefficient. Endurance is everything. Their metabolism runs low, conserving energy rather than spending it. Transparency aligns perfectly with this economy. Pigment production requires amino acids and complex biochemical pathways. Thick exoskeletons require calcium and structural proteins. Muscle mass demands constant energy even at rest. By minimizing all three, sea spiders reduce their daily energy costs to the lowest sustainable level. This is an evolutionary trade-off. They sacrifice speed, strength, and reproductive output for longevity and persistence. In a stable but harsh environment, surviving longer increases the odds of encountering food and reproducing successfully. Evolution does not reward excellence here. It rewards patience. Sea spiders challenge the human instinct to equate complexity with success. Their transparency is not an anomaly, but a logical outcome of evolutionary pressure applied over millions of years. They demonstrate that life does not always advance toward greater power or intelligence. Sometimes it retreats, simplifies, and survives by becoming almost invisible. Studying these organisms exposes the limits of our biological assumptions. We still do not fully understand how diffusion alone sustains their tissues, how neural systems function with such minimal structure, or how many undiscovered forms share similar strategies below. The deep ocean remains largely unexplored, not because it lacks life, but because life there refuses to announce itself. Transparency in this context is not eerie, it is honest. It reveals how little is required for life to persist, and how much of evolution happens beyond human perception. The more we study these nearly invisible beings, the clearer one truth becomes. Survival does not always look strong. Sometimes it looks like disappearance.